So today I will tell you in detail about a tool which is used with Terraform as a wrapper. It's Terragrunt. So I will be talking in both languages, Hindi and English mix, depends on what I'm trying to explain. So starting with Terragrunt. So the basic definition, and today the agenda would be that I would introduce you to Terragrunt and the definition and the purpose, and why should we use Terragrunt, what are the challenges in the Terraform orchestration that Terragrunt helps us to overcome, the advantages of using Terragrunt, how it works, and the key features. After that, we would do comparison, or what we say is that they are somewhat more similar. Terragrunt is just extended abstraction of Terraform. After that, we would go to the Terragrunt installation, and there is a simple practical in which we will be launching VPCs in different environments. I've taken VPC because VPC is just like it's granular, means in any infrastructure. At first, we set up VPC. So I take the VPC example because it's quite simple, and it would be really easy for all of us to understand how Terragrunt help us to optimize the code. And then we would talk about the alternatives and whether it is better than the Terraform workspaces or not. So let us start with the definition. So as you can see, it's popular open source tool, and it is most commonly used with Terraform. So what it does, it provides extra tools for keeping your configuration dry. Dry means do not repeat yourself. Means when you are running Terragrunt on the ground, it's still running the Terraform, but just before it generates some configuration and run the Terraform with specific options. Means it's like a layer of abstraction over Terraform. So when someone asks what is dry, so whenever you feel that you are writing the same code with Terraform again and again in different modules, Terragrunt is going to be very helpful. So managing remote state, handling multiple environments, and executing custom code before or after running the Terraform. We'll get into that. So you would be able to understand how we are able to manage the common aspects of all the modules within the Terraform root directory, and how Terragrunt helps us to emulate all these common values within all the defined modules. So why are we using Terragrunt is because in Terraform, while setting up the infrastructure, we are limited to a single environment. And if there is a project or any use case in which there are multiple environments, you will need to duplicate the same code for each environment. So what is that same code? So that part is basically the backend of the state file you're trying to save, as well as the providers. So we would talk in detail about that. Just right as of now, what I want to say is that Terraform helps us to deploy infrastructure in different environment with the help of workspace. But workspace is just limited to your local machine. When it comes to a broad aspect of different accounts, different environments, workspace is not that efficient. I mean, even in workspace, you would have to repeat the code, the modules and everything. So Terragrunt's capability to deploy resource across multiple environments not only reduces code duplication, but also aids in efficient management of environment configurations. Environment configurations means, for example, we have 3 different environments: stage, QA, and production. Now, hello. So for different environments, we would be using different type of resources. Means for production, we would be asking for more powerful CPU and memory optimized resources. For QA and stage, maybe lesser. So we can decide what type of resources we want to deploy in different environments using Terragrunt. So next we come to the main thing about Terragrunt is how it works. So as I said, it's just an abstraction. It's a layer of abstraction over Terraform. So on the left side, you can see This is just a basic Terraform root module in which we have a stage environment. Then we have two applications, or we can say two resources. One is front end and another is MySQL database. So both have main.tf. This is normal Terraform file, means in the main.tf we would be having the Terraform block in which we would define the resource or from where we want to fetch the module, and then the resource block in which we would define the resources that we want to siphon up from the provider and run it in the infrastructure. So this is basic Terraform module, root module. Now, when it comes to Terragrunt, what it does is within every module, it would create a simple file that is terragrunt.html. What is this .html? It's an extension, HashiCorp language extension for siphoning infrastructure as a code. The same we use with Terraform. So it is placed in the root directory as well as in every directory of the modules. So how this works and how does it tells the root the child directories to run the same configuration while applying the Terraform, I will tell you further on. The main thing I want to tell you is that if you would see over here in front end app, there is one terragrunt.html, and in MySQL there is another terragrunt.html. So what I can say from here is this is the root terragrunt.html file. This would be controlling all the child terragrunt.html files in the modules. Now, why does it do that and how it really controls over it? We'll see in the DIY practical. So this is how it works. Now, if I would show you a simple example of how this particular HCL file helps us. So I would go to the official documentation. You can just search for Terragrunt and just go to quick start. Over here in quick start, you would get everything starting from the basic features and how to install it and everything. So I would just straight away come to this terragrunt.html file, which is the root file, which I'm talking about over here. Now it can be these file as well, but depends what we are trying to do. So if say for these two modules, I want to use something commonly, means the backend or the provider, that I would define in this Terragrunt root HCL file. And the individual modules means the front end app and the MySQL app, in which I want to proceed with specific inputs. That inputs I would put in terragrunt.html child files. So how all of these interact with each other, we'll see in the official documentation. So the main block in this terragrunt.html is Terraform block. So basically here we define the source. Source means from where it is going to fetch the modules, and in that particular directory it would at the backend it runs Terraform only, so it would run Terraform plan or apply whatever we done. So it would fetch this particular module, and right after that there is a generate block. So this generate block is really good, as on the fly it creates providers. So in Terraform we define providers in the main.tf or a different terraform.tf or alag directory, but over here in terragrunt.html on the fly we have this block, generate block, in which we can define that first it would check in the local directory if there is a provider.tf. If it exists, it would overwrite it with Terragrunt configuration that we would define over here, means what provider we want to use, what region we want to use. Now see, this is common for all the modules. Now we won't have to define this again and again in every module. We just define it in the terragrunt.html root, and the child would automatically pick it up. How it picks up? There are different arguments that Terragrunt utilizes. Well, there are a lot of arguments, but I would be focusing on just the basic ones so that you get the clarity of how it works. Now the third thing is input. This is the input which I was talking about, specific to the modules. Means in front end app, I want only the input of T2 micro instance or a specific security group port that needs to be enabled. I can define it in the input. So this is just a overview of what is that HCL file. Now moving on, after this, These are some key features that Terragrunt helps us to implement. First is remote state management. So it simplifies remote state management for projects. It can automatically configure and store state files remotely in services like S3, GCS, and any other backend which is supported by Terraform. Again, DRY, I told you that we don't want to repeat the same modules, same code over and over again. So it also helps us to follow the DRY configuration. Again, it also helps with this dependency management. Means different Terraform modules and states, how are they dependent on each other? We can define in the HLC file. Also, it also helps us with configuration inheritance. So modular configuration, whose parameter we can use in the child modules. Basically, that's what means by configuration inheritance. So the next is environment specific configurations. Means it supports creation of environment specific like dev staging prod using HCL configuration interpolation. Interpolation means using predefined resources to define new resources. So HCL language helps us with that, and that's the key feature why we are able to reuse a specific root HCL file in different modules. Then again, remote backend configuration that I told you about. And another thing is locking mechanism. I would explain this locking mechanism after the practical so that you have better understanding of how the locks are created and how Terragrunt manages the lock locally. So these are some key features. Now, according to the official website, the key features are these. So these are just random points I put jotted down just for you to understand easily. But if you would go to the official documentation, these are the 4 basic features of Terragrunt. So how does it help us to keep our backend configuration, provider configuration, and CLI arguments dry? I would tell you in this particular example. So if you can see, this is how we define backend normally in Terraform. Means the bucket name, the key, the region, whether encryption is true or not, and the DynamoDB table. So over here, this only can be used within a single module. We cannot variabilize this. Means var.terraform state bucket. This will not work because Terraform doesn't allow us to variabilize the backend. Here comes Terragrunt. It says that no worries. You don't have to define variables. We can just define it in the root module and every other modules would use it. So how it is defined is that within the same functionality of this directory, there is a root terragrunt.hcl and particularly to terragrunt.hcl in both the modules. So now we come to the main terragrunt.hcl. What is it is the root or in the stage modules. So this is the configuration in which we have this remote state argument in which we have path of the backend.tf. Now what is this path? So whenever I run Terragrunt init or apply in a particular directory, it would check over there whether there is a backend.tf or not. And if it exists, it would override with this configuration. Means the bucket name, the key, the region, the encryption, and DynamoDB table. The same configuration we did it in the Terraform, we would be doing over here in config block. The only difference is this parameter, path relative to include. What does this really do is that it checks the path. Means for this is the root terragrunt.hcl in which we would be defining the path relative to include, and all the others module terragrunt.hcl, that is the child terragrunt.hcl would be having this configuration, that is include root and find anything that is in parent folder. So what it says is the parent folder, the find in parent folder helper will automatically search up the directory tree to find the root terragrunt.hcl and inherit the remote state configuration from it. So it would check this parent, both of them, and check the path relative to include, means the path of this particular key. It would automatically fetch it, and this key would be generated within the S3 bucket by the name of the path relative to include means if it's in the front end app path, it would take that key. If it is in the MySQL path, it would take that key. So this is how Terragrunt is helping us to manage all the modules with a single root module HCL file, and we can configure the backend commonly for all the modules. So right now I would stop it over here. If there are any questions till now. Okay. Moving forward. So this I told you about the backend. So I would also do it in the practical. So you would be having better understanding over it. Now coming to the provider configuration, right? So same as backend, we can define the provider configuration in the root HCL like this. It would check if there is a provider.tf in the root where we have run the Terragrunt in it. If it exists, it would overwrite it with this value. And this value would be common for all the modules. If you want to add another provider like EKS or any other plugin provider, you can include it over here and it would automatically be inherited by all the root HCL files. So this is another feature. I would also explain this in the example. Then after that, this is CLI arguments, means whenever we are defining any variables within the Terraform file, when we do apply previously, if we are not using tfvars, we would define it with this -var-file is equal to the variable we are using while Terraform apply. But with Terragrant, you can simply define it within the root, that root file, that extra arguments is common variables, and what command should automatically add those arguments. We can add over here. Either we can add commands specifically, or we can just tell it that get Terraform commands that need wars. So this is another internal argument built-in function which is by Terragrunt, which helps us to keep it more settled. And the next feature after this CLI is one more thing. While running Terragrunt apply, we don't need to specify the variables. It would automatically pick up the extra arguments from this CL file and apply it. The next feature is promote immutable versioned Terraform modules across environments. Now, what does this mean? It's that we can define our modules, specific modules. Means right now, if in this example you'll see, it's taking the source from open registry, Terraform AWS module VPC. It's taking the VPC module with specific version defined over here. So this source is for that module from the open registry. Now, if you want your specific modules to be fetched into HCL, and you want to create immutable and this particularly this version Terraform modules, means within a single repository you would be maintaining the modules, and in other repository you will be maintaining all the environments and HCL configurations. So the thing is that every time you would be changing anything in different environments, it would be really easy. So how it works, how does this configuration works, I would tell you in the example I would be showing you. So the thing is that there would be two repositories. One repository would contain this. Means, for example, there is a repository named infrastructure modules. In that infrastructure modules, we have production, QA, and stage. And within every production QA stage, we have app MySQL VPC, and just like that. So if this is the particular repository, within the app folder and main.tf, we have this. Means the things we had defined previously in Terraform, the same we would be doing over here. Then in output.tf, we have this, the output, and then variables we want to define, we would be defining over here. This is in the infrastructure modules repository. So if these are the two repositories, one is infrastructure module, one is infrastructure live. So all the modules would be in this. All the modules means the app module, the main.tf for app, the main.tf for MySQL, the main.tf for VPC, everything would be in this particular repository. And there is another repository, infrastructure live. In this, we would only be having the HCL files. That's it. We don't need to define anything over here. And this in this HCL file, the source I told you about, right? In the source, we were using that open source registry link for the VPC module. But over here in all these terragrunt.hcl files, the source would be the GitHub repository of infrastructure module. Means these modules would be fetched first when we would be running Terraform, the Terragrunt plan or apply. It would fetch the modules from this repository, copy it over here in the working directory in which we had run the Terragrunt apply or whatever, and then it would siphon the providers and everything. So this is common within all environments. I mean, infrastructure live means all environments, prod, QA, stage, all environments. So we are using single module with Terraform HCL configuration for different environments. So it's immutable, and we can also do versioning. And how is that? If we would be doing any changes in different branches of that particular repository, we would normally push the updated code with a tag. With that tag, we can define that tag in the source only. Over here, if you can see with the ref parameter, we can define the version of that tag. Simply, it would take that particular version from the modules, clone it into the working directory, run Terragrunt apply, and it would apply the modules easily. So these are the 4 features. I just gave you an overview of how these works. Now, if you can see over here, this one is for the production. Means for this production app terragrunt.hcl, I can define specific inputs. Means if I want to run M4 large instance with instance count of 10. Now I don't want that same in QA, so simply I would just put the input differently for QA, and for stage I can control granularly the particular inputs and variables for any module just by configuring the HCL file. So this is just an overview of all the points. I would explain them in the example briefly, that we would be having better clarity of how Terragrunt really works. So any question till now? Okay. Moving forward. So there's another slide I wanted to include in this. It's just to tell us that Terragrunt and Terraform are no different. Terragrunt is just an abstraction over Terraform. And there are some differences, like I just told you now that remote state management, we have to maintain separate state files per environment. But within Terragrunt, multiple environments can be in a single HCL file. So basically it's an abstraction. There are no differences. Only thing is there are yet another tools we can use instead of Terragrunt, but Terragrunt is most prominent because it works handfully with the backend configuration and providers. So this is the comparison. Now moving on, the installation of Terragrunt. So if you have installed Terraform in your machine, Terragrunt is just an abstraction, so there is no hard and fast to how to download it, how to do it. Just download the binary, rename the binary, make it executable, and move the binary to local bin so that you can run the command from anywhere, and then verify the installation. It's just as simple as that. And you would have to just create the HCL files, put it in the particular modules, define the values, and start using it. That's it. It's same as Terraform. So I've already installed. If you want to try installing it, you can go ahead, and you can also go to the official website. You can see the steps. It's pretty easy. So now we come to the practical. So in this practical, I'm keeping it real simple. So we have one directory, infrastructure live, in which we have production and staging, and I would be only creating VPCs over here. So we would be having one VPC in production, one in staging. And what would be the key takeaways from this practical is that we would be able to identify how to keep our backend configuration DRY, provider configuration DRY, our CLI arguments, and the immutable inversion modules. So that is not included in this example, the immutable version of Terraform modules, but you would get to know how it works. Okay, so moving on to the practical. So I've already created an S3 bucket for the state file management and everything. We're deleting everything for now. So the user I have configured with the AWS CLI has the administrator permissions, but still we would have to include some policies within the bucket. So this is the policy only for us to access this through ARN. Okay. So according to that, let's create a directory infrastructure live. Within infrastructure live, let's create two directories: production, staging. Just a second, guys. So within production, we would be creating a directory VPC. Same within the staging. Within VPC, now we like Terraform over here, just a simple HCL file. Similarly for the staging. Now within the root, another Terragrunt.html. This is for the backend and provider configuration. Okay. So within this particular root module, I would be defining the common things that we'll be using between different environments, like the remote state that we just read on the official website. So just a second. So if we would going to remote state, here we don't need DynamoDB table as of now. Now bucket name is Terragrunt. Okay, yes, yes. No. Okay, so this is the remote state which is common for the production staging module, and then we'll add the generate provider configuration. So for provider, I think it's over here. Okay, so this is the generate provider configuration, right? Okay. Yeah, that's it for the root file. Only these two things are common. Then if we will go to the production VPC Terragrunt, now over here we would first define the what this particular child HCL file should do. So it should find what is in the parent folder, include it in the root. So we would just simply copy that. If we would be going to the backend. Okay, so this is the one. After this, we would define the source from the Terraform block. So if you can see over here, the source is the VPC. Now this version is outdated. Latest version is 5.1.2. Okay. So this would be the source from this particular from where this particular HCL file would be fetching the module and then running Terragrunt apply over it. Now for this specific production VPC, we want some specific inputs. Now I would be giving those inputs over here only. So if I would take this and it's production, the CIDR and AZs and private subnets, their CIDRs, and whether we want to enable NAT or not, all these things in this. So this is for the production where we have defined the tag environment as production. Similarly, we would be doing it for our staging. So if you go to staging, save it. Okay, so that's it. We have done it. So the last thing I talked about the immutable and versioning. In that, if we want to define any specific modules that we are using for our infrastructure, we can define it in the source over here. And simply it would fetch that module from that different Git repository, and we would be having that immutability as well as versioning if we are using tags. So this is the root in which we have common remote state and provider. This is the childs for production and for staging. So if I simply run Terragrunt init, I have installed Terragrunt previously from the same step I told you about. So you would be needing Terraform before this. Okay, so first thing we notice is that it created a .terraform.log.hcl file and a Terragrunt and also both the backend and the providers are also created. These are common for all the environments. That's why we are able to see them over here. Now two things. In Terraform, if we want to run the production infrastructure, we would simply go to the production and then run Terraform apply, and it would only apply the production. And if we want to do staging, we would go to the staging directory and do Terraform apply, and it would run the staging infrastructure. But with Terragrunt, we can run all the infrastructure all together with a single Terragrunt all command. So if you would be going to the official website, over here you would be able to see just a second. So the motivation behind this, you can read it, but the run all command helps us to run everything at once, destroy everything at once, plan everything at once. So this is over here. So I'm not going to do it as of now. I would do individual. then I would destroy it altogether. Okay, so if I do Terragrunt plan in this production directory, just a second. So you can see in the backend it's using Terraform only. It would initialize the backend and provider plugins, and after that it would tell us that what must be. So these are the default values from that particular open registry module that we are fetching through source. Everything and anything would come over here, but if you want to define specific inputs, you can do it over here, just as I told you. And in the child HCL files, you can define the inputs whatever you want specific to that resource. So simply run Terraform, so Terragrunt apply. So now we can easily see what Terragrunt helps us with. See, we don't have to repeat anything. If there are many other environments, many other accounts, and in different cloud providers, it would be really hectic to maintain the same code in every other place. But with Terragrunt, you can easily control it with the root module, with the root HCL file for all others module, meaning the common things, and so, anything which is not common means the difference, the basic difference between different environments, you can define it in a particular module HCL for that specific module. So you have that granularity over that modules as well. So right after this is created, we would able to see the backend, like the state file, and if you want to maintain the log file as well. But we don't go ahead and maintain the log file in Terragrunt because it has its own feature of maintaining the log file. Means before Terragrunt runs, before it applies the Terraform, it checks locally whether there is a log file or not. And if it finds a log file, it automatically uses that log file and copy it in a temporary cache folder while running the Terragrunt apply command. It uses that log file so that you can match the same infrastructure that is running over there and also where you are running the Terragrunt apply command. Now, right after the Terragrunt apply is finished, it would again copy that new log file in the cache folder to the root module log file, means this file. It would copy it in the this if I can, it would copy this terragrunt.log from the cache, and then you can simply push it again to the repository and the lock is maintained. So there is no race condition between developers or you and your teammates if you're doing that. So that's why I haven't defined any locking for DynamoDB, locking configuration to be saved in DynamoDB, because Terragrunt flawlessly handles it within the directory only. So if you can see, the production VPC must have come up. So if I would go to the S3 bucket, you can see over here we have production and then VPC, and there is our state file. Similarly, our VPC we created. Okay, so this is the VPC, and similarly I can do that with the staging one. I think I haven't defined this name. Just a second. For staging, I would give it Now, instead of doing this, particularly for different directories, I could have applied it all together. I'll show it by destroying it altogether. But if you want to try, you can do this as well. So this is the cache. Every time we run apply, it creates this cache and copy the log file from local to this cache, runs the apply, and after apply again copy that log file from cache to this log. And right after that, if you would push it to the repository, you would be having the updated log file, no race conditions. So that's how it handles internally. Any questions till now? Guys, am I audible?
Yes, Ashwit, you are audible.
Okay, IP error. So see, for staging as well, we have a different state file. So what is happening over here, right? Where we defined particularly what backend it should use. If you can see over here, this particular argument path relative to include is helping us to differentiate the state file for different modules. Means for staging it's different, for production it's different. So there is another state file over here. Here's some EIP error, but we would ignore that. As EIP, my account has run out of EIP, so I would fix it some other time. Now I want to destroy it all together, so I would simply run terragrunt run -all destroy. So it would tell me that within group 1 I would destroy this, and then production, and then staging. So I can do this with a single command. Okay, so that's it on the practical side. Do you have any questions in this configuration and how it works? So as I've told you, this is for within, I'm doing it in the local. If you want really, you can use the source as different Git repository over here, from which you would fetch the modules and how you want to use it with the inputs for particular environments. So that's how easy as it gets, as dry as it gets with Terragrunt. Now moving on. So we did the practical. We created infrastructure destroyed with Terragrunt, and we kept that backend configuration DRY. We get the provider configuration DRY, and also we promoted immutability and version within our constraints. If you want to try out with different repository, you can definitely do that. There is step by step in the official documentation. Moving on, now I will talk about the alternatives and comparison of Terragrunt with Workspace. So it has many benefits, but it also adds an additional layer of complexity to your infrastructure management and may require a more initial setup. It is also another tool to manage and doesn't work with Terraform Cloud. If you use that, you will need to educate and train your team on the use of Terragrunt, which will create additional cost. Now, you may consider using pure Terraform to be sufficient for your project, as it will support many of other features natively, which will not be as feature rich as Terragrunt, but may suffice. say multiple workspaces that I told you about and remote state. Now there is another tool, TerraSpace, which is a fully fledged framework for Terraform, which offers further benefits over Terragrunt. We can do it in some other sessions because with this Terragrunt, it's not done means there are lot other features and lot other arguments that are used, the internal functions that Terragrunt uses. So it would take further 1 or 2 sessions more for you to get totally hands-on with Terragrunt and how it works with different cloud providers as well. So we can do that. Another is Spacelift, makes it easy to work with Terraform and Terragrunt. If you need any help managing your Terraform infrastructure, building more complex workflow based on Terraform, and managing AWS credentials per run, instead of using a static pair on your local machine, Spacelift is a fantastic tool for this. So we can also look at Spacelift. So these are alternatives for Terragrunt, like TerraSpace and Spacelift. So Terraform also offers a features called workspaces, which helps us reduce code redundancy and enable provisioning of different environments. So when using Terraform, a separate state file is created per workspace, that we know. However, the workspace are not a good option for are a good option for local development and testing purposes, but for production grade deployments, it's not recommended by Terraform as well. And the official documentation recommends to avoid using workspaces for managing multiple environments. Also, Terragrunt handles the deployment of resources to different environments efficiently, not only by using a single command, but also gives good visibility and control over source code for infrastructure provision that we saw. And Terragrunt is an ideal tool. So for large and complex infrastructure. So that's it. Thank you. And if you have any questions and answer, I'm ready to